Very cool. Taking a step back to help me understand the kind of work that you do at your company, something that might help us would be to have some kind of general sense if this is possible. It might be tricky with the different kinds, so many different kinds of industries that you're serving, 8,000 people just in your semiconductor part and the electronics part of the business. I imagine this could be tricky, but would you be able to give us some kind of generalization or maybe a few examples of a key kind of client? Maybe you don't need to mention them by name, but just a key kind of client that would come to you and make a request. And then how do you fulfill that request? How does your business cycle kind of work?
If you allow me, I would maybe start with, so how is a semiconductor, how is a chip being made? How is that happening? So it's in today's technologies of all the big chip companies, they use a similar approach. It's a couple of hundred and more than 1,400 steps from a blank wafer to a ready-made semiconductor device. Mainly,
And
yes.
and what's a wafer?
Oh, so wafer, that disk, a silicon disk. It's a 300 millimeter sized disk, like a, for the kind of more seasoned folks listening, it's like a record in the past. So some people may still know a record. It's the exact same size, 300 millimeters. It's a very thin silicon disk, and on that disk is you kind of put materials on top in order to build transistors, in order to build kind of the power lines, the data lines on that, and then you cut these disks into small dies, centimeters by centimeters size dies, and these are the chips. That's what we call at the end of the day chips. And once they are cut, and to make these transistors work, you need materials. You need ways to structure your materials. This is called lithography, like photolithography. And then you build with so-called thin film technologies. You build lines and transistors on these silicon wafers on these disks. That's how it's being made. And this is 1,400 steps from a blank wafer to a functioning semiconductor device. That's what it takes, and it's always the same steps: lithography, patterning, deposition, cleaning, planarization. Always these kind of steps happen over and over and over again until that chip is made and it's working.
Very cool. And then, so now that we have some sense of the process, tell us how the materials business supporting that semiconductor industry works.
So then you need a number of specialized materials in order to create that. So of course, the one which is probably known to still to many people is for the photolithography. You need what is called a photoresist. This is like a kind of a chemicals image and a photo in the past, and that how it was done with a photosensitive layer that kind of creates a positive or negative image on your surface. That is only the beginning, because then you start building structures on these lines by edging away stuff that you don't need, by depositioning stuff that you need, by planarizing the surface in order to build the next layer of materials on top of another. These are specialty materials. They cover currently about 80% of the non-radioactive periodic table of elements. So if you had chemistry in school, you know the periodic table of elements, and if you take that full picture, a couple of them are either radioactive or they have a pretty short half-life, so they're not being used. But 80% of the rest is actually being used in making semiconductors. And so most of the examples I'm currently using, they are based on what we call a logic chip. This is a CPU, a GPU, everything that does any kind of logic switching. The other kind of big area for semiconductors is memory chips, everything used to store data on a permanent way, on a dynamic kind of a short-term way. So these are different levels of memory being used, but most of the examples I'm using here, whenever I talk about the transistors, it's more on the logic chips, kind of the main area that drive compute right now in the world.
Very interesting. And so now that I've asked about the business in general and we understand a little bit more about semiconductors, you've been working at your company since 1989. Tell us about how you got into that and how you grew into this leadership. The thing that's interesting to me about this question, I don't usually ask guests on air how they grew into what they're doing today. But in your case, I think it's fascinating because it's this highly technical field. And you're obviously very much on top of those technical aspects. You've been doing it for a long time. How does somebody become expert in semiconductors and then grow into a leadership position like you have?
Yeah, it wasn't such a straight line as it probably hindsight it could be made. It was more, let's say, a path through very different assignments. I left after I studied computer science with a very deep focus on semiconductors already. I left university, and I was working on semiconductor design back then, improving semiconductor design in the late 80s. This wasn't such a sophisticated area as compared to today, but still, it gave me, of course, deep insights into what semiconductors are. And after being a research assistant at that place, then I was attracted by joining industry in a very different area, more in my, let's say, uh, old home turf in software, and I worked in our corporate IT for quite a couple of years, more in the database space, and doing consulting for process improvement. So these kind of things that brought me then, and I skip now probably 2 decades. It brought me then into the business as well, running a country organization, selling our materials and our solutions, and with another steps. Then I was heading for a couple of years HR. More as a board member and a kind of a more a general practitioner rather than a specialist in HR. But it was times of massive transformation, and I think our owners wanted to have probably a person that has like practical knowledge of leadership rather than just a specialist. And so then we drove the transformation of the company from with an HR lens, and then again, a couple of years later, I was asked to head our electronic materials and solutions business in our company. That was, of course, a great opportunity because it brought me back to where it all started, to semiconductors. And this is why over here it is the leadership part, which is exciting, as well as the deep technology, where I believe I do have still quite some knowledge from the late 80s, which I refreshed. Of course, I polished it a bit over time, but it's exciting with the team not only to talk about the P&L and the growth plans and the strategy, but to talk about technology. I love to go to the labs and see that. I was just there a week ago and saw a new tool being used there for atomic layer deposition, and talking to the R&D folks. That makes me really excited. This is what brings me to work every morning.